Welcome. Today we are going to attempt to prove or find an equation for the sum of a finite arithmetic sequence. So before we get started on that proof, let's look at what the terms of a finite arithmetic sequence would actually look like. So when defining an arithmetic sequence, you're always going to start with a first term. So we'll let a sub 1 be our first term. Our second term, and how you get to successive terms in a arithmetic sequence, is by adding a common difference, which we'll denote using the letter D. So the second term would be the first term plus the common difference. Okay, so we're going to just keep on with this pattern. A sub 3 would be the previous term, a sub 1 plus D, which is also a sub 2, plus a common difference. Or we could write that as a sub 1 plus 2D. All right, we'll do one more and then see if we can figure out a pattern here. A sub 4 would be the previous term, a sub 1 plus D, which is the same as a sub 3, plus an extra common difference. So we could also write that as a sub 1 plus 3D. Okay, so we've written out four terms now, and note that we can always add 0 to anything. So I'm going to add a 0D to my first term. And if you'll notice, the number of the term in the sequence is one more than the coefficient of D. This would have a 1. Okay, so when we try to start writing what the nth term would look like, the a sub nth term would be the first term plus coefficient of D would be 1 less than the number of the term. We could also back that up. We could look at the n minus 1 term, and so that coefficient would be n minus 2. So now we kind of have an idea of what the terms in our arithmetic sequence look like. Okay? Keep in mind, a sub 1 denotes the first term in the sequence. D is used as our common difference, and a sub n is representing an arithmetic sequence, and n is our counter. Okay, so now what we want to try to do is sum this sequence. Okay, so what we're going to do is we're going to take all of the terms on this side of the equation and add them up. So we have a sub 1 plus a sub 2 plus a sub n minus 1 plus a sub n. Okay, so that's one way that you could write that sum. Another way that you could write that sum would be using the expressions on the right side of the equation. So if we look at the expressions on the right side, s sub n would be, and then this way we can get everything in terms of a sub 1 and the common difference. We would have a sub 1 plus, remember that a sub 2 is a sub 1 plus D. A sub 3 is a sub 1 plus 2D plus a sub 1 plus 3D plus plus a sub 1 plus n minus 2D plus a sub 1 plus n minus 1D. See if I can get that where you guys can see it. Okay, so we've written this in ascending order from the first term to the last term in the sequence. Now we're going to turn it around. Similarly to the way we proved the sum of the first n integers, we're going to write this in descending order now, from the last term to the first term. So S sub n is also equal to a sub 1 plus n minus 1 d, that's the last term, plus a sub 1 plus n minus 2 d, plus plus a sub 1 plus 3d, plus a sub 1 plus 2d, plus a sub 1 plus d, plus a sub 1. So we've written this two different ways, very similar to the method used in proving the sum of the first n integers. We are going to add these two equations together. And we will get that we have two sums, the nth sums, plus, and if we look at these terms right here, that gives us 2a sub 1 plus n minus 1 d. If we take the second term and the n minus 1 term, we still get 2a sub 1's, and then this has a coefficient of 1, this has a coefficient of n minus 2, and if we add 1 and n minus 2, we get n minus 1. So that would be n minus 1d once again. The next one, you would have 2d, and then if we kept on with this pattern, it would be n minus 3d. So positive 2 and n minus 3 would still give you n minus 1. So you're going to have several terms that look exactly the same. And keep in mind that you have the terms, the first term all the way through the nth term, so you have n terms. Okay, so you have 2a sub 1 plus n minus 1 d, but there are n of those. Okay, continuing on. If we look back at the nth term is defined to be the first term plus n minus 1 times d. So if we break this apart, 2 s sub n's is really equivalent to the first term in the sequence plus the last term in the sequence, all times n. And then at this point, all there is left to do is to divide by 2. So the sum of the nth sum, the sum of the finite arithmetic sequence from 1 to n is equal to n over 2 times the first term plus the last term. And so that's your closed form.